right, last bit of information I wanted to go over today is writing equations in standard form. So you've seen standard form for a while. We know what it looks like. It is this y equals ax squared plus bx plus c. All right. Now, what we've done mostly is started with this and either factored it or completed the square or used quadratic equation. Now what I'm going to do is have you do the opposite. I'm going to tell you what the roots are of the quadratic, and I want you to put it back into that standard form. All right, so let's just start running into some examples, because basically what we're doing is undoing everything that we just did. And this is just giving you more and more tools to be able to manipulate and solve quadratics. All right, so if I tell you that the roots of a quadratic are 2 and 3, what that means is that if I set my factors equal to 0 and solve, I would have x equals 2 and x equals -3. Right? Turning those back into factors, I'm going to move my constants over, so I have something equal to 0. So this is going to give me x minus 2 equals 0, and x plus 3 equals 0. All right? Well, that looks an awful lot like factors. And what do we do to get it back into standard? We're going to take those factors and we're going to multiply them together. So we have x minus 2 times x plus 3 equals 0. Right? And we're going to start multiplying these out. We're going to do distribution. So first, then inner, and then outer, and then last. Right? Just like we've been doing. So this is going to be x squared minus 2x plus 3x minus 6 equals 0. Then we've got some like terms to put together right here and here. So it'll be x squared plus x minus 6 equals 0. And that is the standard form. Right? So let's do another example. Come over here and we're going to look at, roots of 0 and 4. All right, that means x equals 0 and x equals -4. We turn these into factors. X equals 0. It already equals 0, so we don't have to do anything. We're going to leave that one alone. And then we're also going to have x plus 4 is equal to 0. That will be our other factor. So then we multiply these together. So x times x plus 4 is equal to 0. Or x squared plus 4x equal to 0. Right? This is standard form. Right? It's just that in this case, our c is going to be 0 because we don't have a constant term. Next example, we're going to have x is equal to 2/3 and x is equal to -1/4. Right? Now we're going to turn these into factors, so we're going to add this to both sides. This is going to give me x minus 2/3 is equal to 0, and x plus 1/4 is equal to 0. Right? These are not super easy to work with, so what I'm going to do is I'm going to multiply everything here by 3. I'm going to multiply everything here by 4, and that's going to get rid of those denominators. So this is going to give me 3x minus, these are going to cancel, so this will be just minus 2. And then 3 times 0 is 0. This is going to give me 4x plus 1 is equal to 0. All right? So we take these two factors now. These look more like factors. And then we're going to multiply them together. So 3x minus 2 times 4x plus 1 is equal to 0. Right? Start multiplying everything out. This is going to give you 12x squared plus 3x minus 8x minus 2 equals 0. Combine our like terms, and I'm running out of room. So this is going to be 12x squared minus 5x minus 2 equals 0. And that is our standard form. I have to remind myself to write a little smaller next time. Let's come on over here. All right, so now a little wrinkle here. Our roots are 4i and negative 4i. But you know what? We're not going to let that scare us. Imaginary numbers need love too. This is going to mean that x plus 4i equals 0 and x minus 4i equals 0. Those are going to be our factors. So we're going to multiply them together. All right. So again, just start distributing. This is going to give us x squared minus 4i times x plus 4i times x, right? And then minus 16 times I squared. All right? So these conveniently are just going to cancel out. So we have x squared minus 16 times I squared is negative 1. Right? These are equal to 0. So it's going to be x squared plus 16, because negative 1 times negative 16 is going to give us a positive 16. And there I have my standard form. Okay, so number 5, I'm throwing a little wrinkle at you here. We want to know what our roots are. Those are our x-intercepts, all right? So I have an x-intercept at x equals negative 1 and at x equals 3. So we do the same thing. This means that x plus 1 equals 0 and x minus 3 equals 0. These are our factors. And we're going to multiply it out. That gives me x squared minus 3x plus x minus 3 equals 0. Combine my like terms, and I have x squared minus 2x minus 3 equals 0. And that is my standard form. Another one here. This one is, remember I told you before about double roots, right? Every quadratic has 2 roots. You can have 2 real roots, you can have 1 real double root, or you can have 2 complex roots. So here, I have x equals negative 2 as my root. That means x plus 2 is my factor. All right? Now, because it's a quadratic, that means this is a double root. So I have x plus 2 times x plus 2 is equal to 0. That's going to give me x squared plus 2x plus 2x plus 4 equals 0, or x squared plus 4x plus 4 equals 0. All right? So just be careful of those double roots. All right, and that should be enough to give you some help with your Delta Math, and I hope that everything is good, and that I have a voice that I can teach with next time.